Hey, welcome everybody. My name is Salih. I'm the organizer of Turkey Power BI and Fabric user group. I'll keep it very short on my side and hand over to Nicola as quick as possible. Uh, I'm also a data platform MVP like Nicola, but I'm not hard worker as Nicola. Today's subject is quite hot one, Medallion architecture. Microsoft, I don't know why Microsoft choose to define this pattern as an architecture. We will discuss about this today. Okay, Nicola, we are all ears. We are listening to you. Thanks for joining me.
Thanks, Colin. Thanks for having me. Thanks for inviting me. It's always a pleasure to present for Fabric and Power BI Turkey user group. So happy to be with you here today. And hi everyone. Good afternoon, good morning, good evening, depending from which part of the world you are currently joining. Hi to see you. Good to see you, Fernando. Good to see you. Yeah. So as you said, this is a very interesting topic, and we discussed before we started. We discussed that it's an evergreen topic. So many different opinions, different things that people consider when it comes to Medallion. So yeah, I'll try to provide my 2 cents and some things that I saw working in the real life, and then I'm very open to discussion with others and see what works, also what works for others, and how to get the most out of this design pattern. Just in case you have any questions, please feel free to drop them. I'll try to monitor chat window while presenting, but Khalil, if I miss the question, please interrupt me, and then I'm happy to address it. Yeah, so just a quick introduction about myself. My name is Nikola. I'm originally from Belgrade in Serbia, but for last 10 years, I live in wonderful city of Salzburg in Austria. Currently working as principal architect for iLink Digital, one of the biggest Microsoft partners in the world, mostly involved in projects that include implementation or migration to Microsoft Fabric. You can find me on web. I'm blogging at data-mozart.com. I also co-authored the book Fundamentals of Microsoft Fabric together with Ben Weissman, and also currently working on another one together with Shabnam Watson, which is analytics engineering with Fabric and Power BI. Other than that, when I'm not working with data, I'm spending most of my time with my kids and watching football. I'm huge Barca fan, as you can conclude looking at this photo. So what do we cover today? Just a brief introduction to our agenda. So first, the Alchemist calling, our why, then the Alchemist formula. So we will talk about and discuss core Medallion principles, then forging the metals, doing deep dive and analyzing some great debates about Medallion design pattern. The Alchemist laboratory, I will show you how to use Microsoft Fabric to craft full Medallion solution, and last but not least, what's in the playbook for becoming a chief data alchemist. So we will wrap it up by sharing some key takeaways and maybe steps do you want to consider proceeding working with Medallion. But let's first try to answer the question, what is a Medallion? Is it even an architecture? There are ongoing debates everywhere, and based on what I heard from Khalil at the beginning, I think he's in my team. Personally, I don't think Medallion is an architecture, right? So I like to think about it as a design pattern for organizing the data. And if you go to Databricks website, so Databricks is the company that first coined this term Medallion architecture. If you go to their website, there is an answer to a question, what is a Medallion architecture? And it says that this is a data design pattern used to logically organize data in a lakehouse. So basically, we've been doing Medallion for years, if not decades. We were just not calling it Medallion. So I would say, again, this is my personal opinion, this is not an architecture, although the term medallion architecture became so frequently used and became, let's say, mainstream that in some cases I really give up and continue using medallion architecture just because people are more familiar with this approach. But generally speaking, think of medallion as a design pattern for organizing the data, no matter how you want to call it in the end. So from a high level point of view, medallion represents, and again this is from Databricks website, medallion represents a process of moving your data, organizing your data in a way that it starts from raw data that you ingest into your lakehouse or warehouse, and then from there you take it through different stages, performing different steps to increase the quality of that data, to perform certain transformation steps to get it ready for the downstream consumption. Why it's called medallion? Because the idea is to have three main layers called bronze, silver, and gold. That's why it's called medallion. And each of these layers represent a different level of quality of your data inside the lakehouse or the warehouse. You will also hear different terms, not just bronze, silver, and gold, terms like raw, cleaned, validated, curated, and so on. So in the end, it's not set in stone that your layers inside the lakehouse must be called bronze, silver, and gold. This was made with the idea of getting this pattern more simplified for the business users so that everyone understands the level of the quality. But in real life, you are absolutely free to call these layers as you want, and also as you find proper for your specific workloads. The question we are asking here, and first we are trying to answer in this session, is why does something so simple, so basically we have bronze, silver, and gold, why does something so simple cause so much confusion and debate? Why do we have so different opinions, so conflicted opinions and discussions about medallion when it was supposed to be a very simple approach? Take your data through the three layers, bronze, silver, and gold, and everyone is happy. So why does something so simple cause so much confusion and debate? When we say confusion, there are tons of different questions coming up that are related to answering this question. First is, for example, do I need a landing zone? Should I apply any transformations in bronze layer? What is a platinum layer? Should my silver layer be modeled as a third normal form or a cleansed version of the source? And many more. I'm sure you heard also dozens and dozens of questions like this. And I'm sure I'm not the only one, but those are some of the most common questions that people are asking when it comes to implementing medallion design pattern. So what is the problem of medallion? In fact, medallion as a design pattern, or let's call it architecture, never mind, this is a great concept that is unfortunately too often misunderstood. In many scenarios, medallion is treated as a rigid step-by-step framework when essentially it should be a flexible approach to make sense of the evolving data landscape. So medallion is an attempt to simplify years of evolution and technical innovation into concepts that can be presented to non-technical users. But simplification comes with a cost. Why? Because it leaves huge gaps for debate, for misinterpretation, and finally for frustration. Medallion is a simple bronze, silver, gold conceptualization of the operating model for running a data lakehouse. An attempt to make a set of complex, flexible technical decisions, easy to understand process to prevent organizations from falling into the data swamps. Implementing a medallion design pattern isn't about following a checklist of instructions. And if you go to the web and find some articles, there are checklists with instructions how to implement medallion architecture or medallion design pattern. But it's not about following this checklist of instructions. It's not about taking the exact rigid process and trying to fit your unique organization into it. Instead, focus here should be on providing your data consumers with a context to organize the data so they understand when it has been cleaned, when it is ready for consumption, and so on. So the idea is to help them to find the data to empower their work as fast and easily as possible. Once you have that, you can fit the processes to your design. There is an important word here, and this is a context. It's easy to document some processes and the technical implementations and put it out into the world as the right way to do things. But that rapidly loses value if we forget the why. So why we are doing something. So we'll try to examine here not just how to implement certain processes, but why we need those processes and decisions we have made along the way. So remember, context when building Medallion design pattern, context is the key. Okay. Let's go back to the fundamentals and explain what Medallion is about. I tried to keep this as simple as possible. As I already said, the same as for the lake house concept in general, credit for being pioneers in the Medallion approach goes to Databricks. Simply said, Medallion design pattern assumes that your data within the lake house will be organized in 3 different layers: bronze, silver, and gold. That's why it's called Medallion. Now you may also hear terms, as I already mentioned, such as raw, validated, enriched, curated, which I personally prefer. But essentially the idea is the same, to have different logical layers of data in your lakehouse, and these layers are of different quality and serve different purposes. So let's do a brief explanation of each of these 3 layers. We'll start with the bronze layer or raw layer. In the bronze layer, we land the data from external sources in its original raw state. That means that data is ingested as is, containing only metadata in addition. The main purpose of the bronze layer is to serve as a repository of the historical archive of source data and enable quick data reprocessing when necessary without needing to connect over and over again to the external data source systems. It's important to keep in mind that the bronze layer contains unvalidated data. That means it's not ready for making any business-related queries or reporting solutions because it contains unvalidated data. In regards to storage format, data is usually stored in the original format, although if you have a possibility, and we will discuss how this can be implemented, if you have a possibility to, for example, split your bronze layer into a staging area and real bronze area, you should then in your bronze area already transform original format to something more performant such as Delta or Iceberg, depending on which platform are you planning to use. In the silver layer, we take the data from the bronze layer. This is conformed and clean data so that all the key business entities, concepts, and transactions are available in the form of the enterprise view for either ad hoc analysis, machine learning workloads, and so on. Here, the data is enriched and validated, which is very important because that means it can be trusted downstream for further analytic workloads. From a data modeling perspective, we see 2 main approaches. One is that data contains more third normal form like tables, like in traditional relational database management systems, or what people are also doing, follow the structure of the bronze layer, just containing the clean data. So we have the same structure as in the bronze layer without any normalization and so on, but the data is copied as one-to-one to a bronze layer containing just cleaned and validated data. From a storage point of view, data should be stored already in some of the performant formats such as Delta or Iceberg, again, depending on the platform. And finally, we have a gold layer, which represents the icing on the cake, I like to call it that way, where data is structured and organized to support specific project requirements. Because this is the final stage in the process, data is additionally refined and additionally cleaned, and in the gold layer, you would also apply various complex business rules business logic, use case specific calculations, and so on. From the data modeling perspective, in most cases, gold layer is implemented through the Kimball style star schema, although you will also find some solutions that are using so-called OBT approach or one big table. Again, some platforms prefer to have this final serving layer in that form, but in most cases, gold goes hand by hand with Kimball style star schema. And definitely data should be stored using most performant data formats such as Delta or Iceberg. The idea is to move data across Medallion layers in order to refine it, to organize it, and prepare it for downstream activities. As you will see, and as you probably know, in Microsoft Fabric, we have multiple ways of moving data between the layers. Depending on your selection, you may want to use notebooks, you may want to use data flows, copy data activity in the pipeline, and so on. We will discuss some of these options later throughout the session. Let's now lay some groundwork because as for example, when you're building a house, you first need to establish a solid foundation. The same idea applies to the Medallion design pattern. So before diving deeper into explaining the Medallion itself, let's first try to shift our focus to understanding some of the concepts that are tightly related to the Medallion. So we will discuss extra landing zones as preliminary areas where raw data is ingested before it lands in the Medallion, raw data that represents the unprocessed data collected from various sources, batch processing as a method of processing the data where the data is collected and processed in batches at scheduled intervals, stream processing where the data is processed as soon as it becomes available, and ETL and orchestration tools which are integral for moving data through different layers or different stages in the Medallion design pattern. So let's first talk about the landing zone. A landing zone is often used as a preliminary area where raw data is ingested before it lands in the Medallion. So we talked about 3 layers, bronze, silver, and gold. Think about landing zone as the 4th layer or pre-layer that we are using to land raw data. Now, should you use or should you skip the landing zone? As usual, it depends, right? Various factors may influence this choice, such as the characteristics of the data source. For example, if you are dealing with external services or software as a service vendors, you might need a secure landing zone to initially store your data before moving it to the bronze layer. Similarly, certain application teams with strict data ingestion requirements may require their own dedicated landing zones. These teams manage the extraction process, ensuring there are no unexpected errors or data inconsistencies. While the bronze layer mainly serves as the area for data collection, you may need this extra preliminary landing zone in larger or more complex environments. So it's up to you to decide whether to label this layer as a bronze. Some organizations might call it a thin layer, pre-bronze, pre-refinement, staging, landing area. So these are all variations, but the idea is the same, to place it outside the typical Medallion setup. On the other hand, there are also some other organizations I saw that who include this staging or landing zone inside the bronze layer design as a sub-layer. Again, this means that an extra landing zone is, as its name suggests, an extra layer, so use it only when it's really needed. When talking about collecting the data and landing it in the bronze layer, we tend to use terms like raw or as is. But we have to be careful with this and not take these terms for granted. Before I provide you with a couple of examples, let me first state this clearly and loudly. Data pre-processing is not the same thing as data transformation. Let's consider complex transactional systems that involve vendor packages with thousands of tables. In these cases, an engineer might need to step in and perform the mediation during the data extraction process. To illustrate this, I will give you a few examples. Some data sources are specific software, like banking, for example, and in certain scenarios, data is stored as an XML file, which consists of only two columns: record ID, which is a primary key, and the XML record itself. So if you try to extract this data directly, you would end up with a very complex and hardly manageable data set. So you may consider using some additional tools to pull that data and store it in a more manageable structure. The same applies to complex ERP systems with their thousands of specialized and interconnected tables. And this is a serious challenge when directly extracting the data. To cut the long story short here, in some cases, the first step from technical system tables to the first step from technical system to ingestion sometimes involve a so-called middleware or custom-built software component, which job is to map complex system tables or proprietary data structures into a simpler and more manageable data model. Now we will discuss differences depending on the scenario and the nature of data that you need to process. To put this discussion about the batch and stream data processing in the proper context, let's briefly demonstrate the key differences between stream and batch data processing. So how the batch processing works. In real life, data may come from different sources at different points in time and so on. So let's say that our first chunk of data just came in. Then the second chunk arrives, then the third, the fourth, the fifth, and so on. In a batch processing setup, we will wait for all these chunks of data to come before processing them at once as a whole or as a batch. That's why it's called batch processing. Now let's see how the same scenario is implemented in a stream processing setup. Again, our first chunk of data arrives. However, instead of waiting for other chunks of data to arrive, we will immediately process the data chunk number one. Then when the second data chunk comes, it's being processed as soon as it arrives. So the same happens for any of the following data chunks that arrive from the source. Discussing the tools for extracting, transforming, and orchestration is crucial, as it can significantly influence design of the process of a medallion pattern. So let's briefly introduce some of the available options that we have on the market. Apache Airflow, this is an open source platform that allows to programmatically author, schedule, and monitor workflows. It's particularly useful for orchestrating complex data pipelines and managing dependencies between them. Apache Airflow is also available in Microsoft Fabric. Then we have Azure Data Factory, which is widely used among organizations that have adopted the Microsoft Data Platform. And it is very effective at creating, scheduling, and orchestrating data workflows. Inside Microsoft Fabric, Azure Data Factory is simply referred to as Data Factory, but the functionality largely remains the same. Databricks Autoloader, which is specifically designed for the Databricks ecosystem, it excels at incrementally processing new files as they arrive in Cloud Object Storage, and Databricks Workflows, which is a managed orchestration service as part of the Databricks platform, which lets you define, manage, and monitor multitask workflows for ETL, for analytics, and machine learning pipelines. When it comes particularly to Microsoft Fabric, ETL and orchestration tasks are performed using the Data Factory workload. But the choice of the tools and services inside Data Factory is more nuanced, as you may choose between a no-code transformation tool such as Dataflow Gen 2, a code-first solution using Fabric notebooks, while orchestrating all of these plus potentially many more activities using the Fabric pipeline. So the pipeline is used for the orchestration. We'll examine some of these features in more depth later in the demo. So I think we now laid a solid foundation. Let's dive into some of the nuances of the Medallion pattern implementation. So you've heard about Medallion and its 3 layers, right? But despite the popularity of this 3-layer design, there is a significant debate about the scope, purpose, and the best practices for each layer. Moreover, the gap between theory and practical application is humongous, really. But let's first discuss the key purpose and functions of each layer just from a high level point of view. In this illustration, I'm using the extra landing zone for blob files and Apache Kafka storage. So inside the bronze layer, or bronze layer here in this illustration acts as the zone for raw data collected from various sources. Data in the bronze layer is stored in its original structure without any transformation, serving as a historical record and a so-called single source of truth. It ensures that data is reliably captured and stored, making it available for further processing. The key characteristics here are high volume, variety, and veracity of the data. The data is immutable just to ensure that we maintain the integrity of its original state. So we don't change the data in the bronze layer, never ever. Silver layer refines, cleanses, and standardizes the raw data, preparing it for more complex operational and analytical tasks. In this layer, data undergoes various quality checks, standardization, deduplication, and other enhancements that improve its reliability and usability. The silver layer acts as a transitional stage where data is still granular, but has been processed to ensure quality and consistency. Its key characteristics are that data in the silver layer is more structured, more query friendly, making it easier for analysts and machine learning engineers, for example, to work with that data. And finally, we have a gold layer, which delivers refined data optimized for specific business insights and decision making. The gold layer involves aggregating, summarizing, and enriching data to support high-level reporting and analytics. This layer focuses on performance, usability, and scalability, with the main goal to provide fast access to key metrics and key business insights. Before we dive into the nitty-gritty details of each layer, let's start by setting our mindset right about the medallion layers. It's crucial to think of these layers as logical, not physical. So when talking about, for example, bronze layer, don't frame it as just one physical layer. Instead, look at it as a logical layer that could span across several physical layers during implementation. So how do we design a bronze layer? The main debate when it comes to designing a bronze layer is what belongs to bronze. Is it more than just raw data? The short answer is yes. You should always add ingestion metadata. At a minimum, capture the source file name or topic, the timestamp of when you loaded it, and a unique correlation ID for the ingestion job. This isn't a data transformation. It's just enriching it with its own origin story, which is invaluable for debugging, auditing, and reprocessing when needed. Whether the bronze layer consists of, these are some of the examples of what is done within the bronze layer. So we take a JSON file that contains 3 fields like order ID, amount, and quantity, and then we add 3 additional metadata related fields such as source file name, load timestamp, and correlation ID. Whether the bronze layer consists of a single physical layer or multiple sublayers depends on the complexity of the data sources and, of course, on the organization needs. Let's imagine the following scenario. Traditional source systems often determine the format in which data must be exported, typically using formats such as CSV or JSON. Consider there is a legacy application that exports data only to a local file storage location. In this scenario, you would integrate the data into your Medallion design pattern through batch processing. And this is a typical processing workflow. The process begins by staging the data in the landing zone, where you perform minimal processing tasks such as decompressing zipped files, comparing checksums, and generating metadata. Following this, you copy the data to the bronze layer, converting it into a format like Delta Lake or Iceberg to enhance the performance. At this stage, you also carry out basic validations to ensure data integrity. Optionally, you might also classify or encrypt the data to protect some sensitive information, if you have any, of course. Finally, you compare and integrate the data within your existing bronze data sets to maintain consistency and completeness. In the data processing hierarchy, the bronze layer often includes multiple sublayers. For example, internal staging area, processing area, refinement area, eventually storage in delta format. So whether the bronze layer is a single physical layer or multiple sublayers depends on the data source complexity, depends on organizational requirements, and depends on the decision on whether to include the landing zone as part of the bronze layer or keep it outside of the bronze layer, as we previously discussed. The bronze layer is designed primarily for storing complete snapshots or copies of data, similar to what you would find in a staging environment in traditional data warehouses. So this layer is especially useful if your method involves fully extracting and overwriting the data, because it allows you to maintain a comprehensive history of all data deliveries. The bronze layer usually serves also as a robust archive, preserving data for many years, which is very important for audit purposes. However, there may be instances where you need to clean up data that has been processed and is no longer required. In a medallion design pattern, archiving data is straightforward when you use an efficient storage format like Parquet or Delta and organize this in folders. But it's important to keep in mind that the bronze layer is not intended for historization of data in the sense of representing a fully processed, slowly changing dimension to type 2 table. So data in the bronze layer is often considered immutable, meaning it is read-only. While you may append or merge data to incrementally grow the data set over time, updates or processing of the data are not typical practices at this stage. As businesses grow and data sources are frequently updated, the database structure, we are talking about a schema, can obviously change. And this evolution can lead to inconsistencies in data processing, which is why it is very important to manage schema changes effectively. The bronze layer is crucial for managing widely varying and ever-changing data schemas as data enters the system. Effectively handling schema evolution at this stage sets the foundation for all data processing and analytics that follow. We have two approaches to handle schema evolution. Schema on read. This method applies the schema dynamically as you read the data. That means that the data is stored without a strict schema in place. The schema is only inferred or applied when the data is accessed during processing, during the data reading process. And this flexible approach requires the system to recognize and possibly adapt to various data schemas right after the point of ingestion. This approach is particularly useful for semi-structured or unstructured data or structured data without any built-in schema enforcement, such as CSV or Parquet files. The opposite approach is called schema on write, which involves defining the schema, like table name, column names, data types, and primary keys, and so on, as you write the data into the storage. With this method, you must define the schema upfront, making sure that the data conforms to this schema right from the start, before writing it. So it's a more rigid approach. When using Delta Lake, if there is no predefined schema, the system will establish an initial schema by using the struct type from PySpark data frame that is then being converted to Delta format. In the bronze layer, schema on read is a common approach where data is stored in its original format without enforcing a schema during ingestion. Why? Because this method, as we said, offers flexibility because it doesn't demand upfront schema definition and gracefully handle changes in data structure. Some of the considerations or things to keep in mind when you decide to go with schema on read. First, relying solely on schema on read does not allow for blind data processing. Why? Because you may need to detect and log schema changes, handle failures, restore data using Delta Lake's time travel feature, or add schema-related metadata for more refined processing in later stages. Also, there are some other considerations about restoring the data and so on. So those are the things that you need to keep in mind, as well as defining the data update method. So do you want to append or merge existing data sets, or do you want to overwrite everything? Also time-based partitioning and so on. Because of all these considerations, in practice, in real life, bronze layer usually combines schema on read and schema on write techniques. Initially, schema on read is applied in the landing or pre-bronze layer. So you first read data without explicitly declaring the schema for that data. Then as you move the data to a layer where it becomes, let's say, queryable, you switch to schema on write. For this critical layer, it is wise to choose a storage format like Delta Lake or Iceberg that supports schema evolution, which means that Delta Lake will allow data schema to adapt as it evolves, eliminating the need to overhaul or reload the entire data set. Technical validation checks are crucial in the bronze layer, as issues with data integrity, accuracy, completeness, and consistency may have significant operational and strategic impact on the organization. Implementing validation such as format, schema, and completeness checks at this stage is essential for several reasons. First, it ensures that the data conforms to specified standards, which help maintain consistency across the dataset. Then, early validation helps in identifying and addressing data integrity issues. In particular, this is useful when applying a schema on write approach. There are different options to perform these checks. You can break them into segments or integrate them during data transfer to the silver layer. And there are different approaches like intrusive or non-intrusive in regards to data integrity. So from this point of view, bronze layer doesn't only serve as a repository for the raw data, but also as a critical checkpoint for data integrity and data accuracy, ensuring that only this data that meets predefined quality standards goes further into the lakehouse architecture. Fine, let's now move to understand how to design a silver layer. The silver layer focuses on cleansing and enhancing the data. Here, formats are standardized for elements such as date and time, reference data is enforced, naming standards are conformed, duplicates are removed, and we also perform a series of functional data quality checks. Additionally, low quality data rows are being discarded and irrelevant data is filtered out. Most importantly, at this stage, data generally isn't yet merged or integrated with data from other sources. So what are the cleaning data activities when it comes to working with a silver layer? First one is reducing noise and removing inauthentic data. That means we need to eliminate irrelevant data, such as unnecessary columns and rows, to enhance data quality and to reduce storage requirements. Handling missing values. So check if there is any missing data within the dataset and decide the approach for addressing this missing data. So options include removal, substitution with a default value, or employing imputation techniques to estimate missing values based on the surrounding data. Removing duplicates. Verify that your dataset is free or duplicate records, free of duplicate records, unless there are some specific requirements, for example, for retention compliance, because duplicates can later distort analysis and lead to inaccurate models. Things like trimming spaces, error corrections, consistency checks, like abbreviations, terminologies, units of measure, and so on, and also standardizing formats, like for example for years, months, and dates. That's a typical example. Other cleaning data activities that we perform in Silver Layer are also correcting data types, fixing data ranges, fixing uniqueness, fixing constraints, masking sensitive data, performing anomaly detection, and many, many more. This list here is not meant to be exhaustive, because writing cleaning rules is a complex task that requires a deep understanding of the data and the business processes that generated that data. Remember, after cleaning, the table structures are generally the same as in the bronze layer. It's important to note that incorrect or rejected data typically is not deleted. Instead, it's flagged or filtered out and then stored in a so-called quarantine table within the silver layer. $1,000,000 question: how should I model my silver layer? Okay, so let's explore this question. This is again one of the hottest topic in entire medallion design pattern. There are many possibilities, obviously, and it is significantly influenced by the number of data sources collected, the extent to which these sources share the same key elements or objects that can be matched, related, and combined across different source systems, and the need to harmonize these overlapping key elements for an integrated perspective. Now, what goes into the modeling here? First, conforming and renaming columns. In a medallion pattern, it's common for the silver and bronze layers to align like straight one-to-one in terms of their tables, though the way data is presented in these layers might slightly differ. In this example here, I am conforming and renaming columns using T-SQL. The next concept, or a way to handle the data, to model the data in silver layer, is called denormalization. In order to optimize query performance in data modeling, you can consolidate data into fewer tables, and by reducing the need for complex joins, queries can run faster. This process is called denormalization. Sometimes it occurs in the silver layer, sometimes it occurs in the gold layer. Again, we will examine some nuances when to implement this in a gold layer. If you expect to frequently reload and intensively read data in your silver layer, it's best to use a more denormalized data model, as it generally offers better performance. Slowly changing dimensions. To build a comprehensive historical record of all changes over time, it's necessary to reprocess data into what are known as slowly changing dimensions type 2. This involves changing tables by adding additional columns such as start date, end date, and is current flag to track changes more effectively. However, this process is complex and challenging, and defining a change itself can be a very different process between the source and target tables. Using business keys, surrogate keys, or generating hash values is crucial in this process. So we have a concept of business key that represents an attribute or set of attributes that can be used to uniquely identify business process or entities. Then they have a business meaning, unlike surrogate keys, which is a system generated unique identifier used to uniquely identify records within a database table. Unlike business keys, surrogate keys do not have any inherent meaning in the business context, and they are primarily used for technical purposes. And finally, hash, which refers to a fixed size result generated from input data of arbitrary size using a hashing algorithm. Now, within the community, there is a debate about whether building slowly changing dimensions should take place in the silver layer or be reserved for the gold layer. Most engineers argue that the gold layer is more appropriate for slowly changing dimension type 2, as these tables are expensive to create and store and are generally underused. So silver tables should mainly contain only current records. However, this perspective, as any perspective, has its own nuances. If your gold layer, for example, involves consolidating and merging various data sources, there might be value in creating a historical perspective in the silver layer, especially when the authentic context from the source is crucial. This is often the case when you are building machine learning models that depend on historical data in its original context. Additionally, for operational reporting, maintaining historical data in its original form could eliminate the need for the operational data store close to the source. So ultimately, I would say deciding whether or not to implement slowly changing dimensions in the silver layer involves many nuances and depends on specific project requirements. A third normal form versus keeping the bronze structure when it comes to modeling in the silver layer. Third normal form is one of the available normal forms in the process of organizing the data in a database, is a special data modeling technique that is commonly used in operational or transactional database systems to reduce redundancy and dependencies. Some practitioners favor using the third normal form or other normalized forms for lakehouses because of the reduced data redundancy, adaptability, and also improved consistency of data that it provides. Despite these advantages, using the third normal form or data vault, for example, for the silver layer, has its drawbacks. While these modeling techniques often improve flexibility and save storage costs, they are generally less favored in cloud-based data architectures due to scalability concerns. So organizations usually tend to build a wide nested denormalized tables because this setup maximizes cloud infrastructure efficiency. So think about your priorities when deciding which approach to use for the silver layer. Is your priority to have a strict data normalization in place without any data redundancy and dependency, or do you want to go with a more simplified approach and just create a one-to-one copy of the bronze layer structure, just containing the cleaned and consolidated data? And before we move on to a demo, let's discuss gold layer. Gold layer may look like a fairly straightforward process, right? So we go with the star schema and that's it. But it's not that simple. So in most cases, star schema will address most of your needs. And when you design star schemas, remember that their role extends beyond just boosting performance. So they are shaped based on how users interact with the data. And that means users can easier navigate and utilize data in a more efficient way. So it's performance plus easy navigation. Loading the star schema involves two primary tasks: loading dimension tables and loading fact tables. Let's take a closer look at each of these tasks. So loading dimension tables in a star schema is complicated on its own by the need to handle slowly changing dimensions, an incremental process that involves comparing incoming data with the existing data in the dimension table. Also, it's essential to harmonize the data before inserting records into the dimension tables. The second thing we need to do is to, so it's a multi-step process. The second step is the loading of the fact table. While at the first glance simpler than loading dimensional tables, it also comes with certain challenges. The primary task here involves replacing business keys with surrogate keys linked to dimension tables. So each row in the fact table includes foreign key references to rows in the dimension table. And during this loading process, you might encounter situations where certain relationships between dimensions and facts in the tables cannot be established. This is what practitioners call an early arriving fact. In such cases, creation of placeholder records becomes a necessary step. While implementing a star schema with facts and dimensions is a popular strategy for the gold layer, they can become increasingly complex as dimensional models expand and new data sources are incorporated. And this growth often results in overlapping requirements that are similar but still distinct enough to require different design approaches, potentially altering design of the gold layer and sometimes even a silver layer. For example, some organizations might add extra conformed or extra curated layers with separate semantic layers for data marts that use star schemas. Also, in some cases, you will find a layer called something like platinum, which highlights their specialized and highly refined nature. Adding this complexity, adding these additional layers obviously adds to a complexity of the entire design pattern and should be carefully evaluated. So don't jump into implementing platinum or semantic layer just because you heard someone else is doing it. Definitely it adds to a complexity and depends on the size of the organization, number of different source systems that you need to integrate, specific semantic model requirements, and obviously specific end user requirements. One big table can also be a viable choice when designing a gold layer. It's the idea is simple to store all the data in a single table. It's fairly easier to manage compared to creating a dimensional model with a star schema. In some cases, it also provides better performance. So for certain types of queries, especially those that do not require aggregating large volumes of data from various dimensions, single big table can offer better performance, and it's also preferred for data scientists and machine learning engineers. These weird guys like to have all of the attributes, all of the features within a single table. However, and I think if there is one thing most of the Medallion design pattern practitioners can agree on, is that star schema design should still be favored over the one big table approach for the gold layer, especially considering downstream data consumption, and especially considering that, for example, you are using Power BI as a consumption tool, and we all know that Power BI loves star schema. Before demo, one more thing, or let's say a few more things, and then I promise I'll show you some of these in action. So simple Medallion primer, simple example that where we will use the same data pipeline for the imaginary retailer. So let's say we have standard domains like customers, orders, products, and we will move them through a Medallion flow. So first, the bronze layer is a few change data capture streams from the OLTP database, and we have the orders raw dataset, which includes duplicates, late arriving records, and soft deletes. Next, the silver stage contains the cleansed and conformed tables from orders raw. Here we have new tables such as orders clean, which has a grain of the order line. It's deduplicated. Customers clean, where we have business keys resolved, and products clean, where we have typed attributes. And finally, we have a gold layer where we can take our pick of modeling approaches like star schema, where we have fact orders with the grain of order line, dim customer implemented as slowly changing dimension type 2, dim product implemented as slowly changing dimension type 1, which are optimized for business intelligence slice and dice use cases. One big table, we can have a table called orders enrich with 69 flattened attributes for a specific dashboard with fixed questions, and so on. Can you just jump from bronze to gold? In practice, yes, but bear in mind that the data transformation steps like deduplication, conformed attributes, and so on, the silver stage will likely be in your workflow anyway. By the way, this is ETL, so the silver layer provides the opportunity to store your data at an intermediate stage. Okay, we will come back to explain workspace design in Fabric when it comes to Medallion. Before that, let's go and show the demo. So we will come back later to explain this. I have some recommendations. So essentially what we are going to build is the following thing. So let me open my Fabric workspace. So I'm using the example from Pathfinder Analytics, and I will share the link to this YouTube tutorial in the chat. This is, in my opinion, this is the simplest and best explanation of creating different layers in Microsoft Fabric. So I'll try to keep it as simple and as quick as possible here, since I see that we are already running out of time. But just in few simple words, what is the idea here and what you are going to build is there is a publicly available data set that contains the data about earthquakes around the world, and it's publicly available at this URL. So essentially what I'm doing here, I'm taking the data from this URL, which is returned as a JSON response. So we need to parse the JSON information. Let me just quickly show you. So what I've created 3 lake houses, bronze, silver, and gold for each layer. And I have 3 different notebooks that are used to process the data for each of these layers. So I'm first using the bronze notebook to load the data into Microsoft Fabric. So this is a JSON file that is JSON information that is provided from this data source. So essentially, I can also go down and analyze every single feature that exists in this JSON response. So how do we load this data? First, I will just mimic the behavior that will be implemented in the proper engineering scenario with the pipeline and parameterized pipeline runs. So essentially, I'm setting the date, start date, which will be 7 days before today, and end date, which will be yesterday's date. So as you can see, it's 16th of December and 22nd of December. And then I'm passing these parameters into my main PySpark code, which will essentially create a JSON file and store it inside the Bronze Lakehouse. So let's run this quickly. In this example, I'm passing these two parameters, start date and end date, from the previous cell. But in the real life implementation, I will pass these parameters from the pipeline itself. So as you can see, it says that the file was saved at in my file section of the Lakehouse. So if I go here and click refresh, you will see that we have a file, a JSON file here. So once the JSON file is stored here, this is our bronze layer in Microsoft Fabric. From there, I will use my silver notebook to process this file. So what I'm going to do, I will first load some of, let me just clear this. So I will load some of the necessary libraries that we need for processing the data. And then in the next step, we are creating a data frame that contains this JSON data. So let's create a data frame. And we will see results immediately here. So I'm loading the data from the JSON file, and here is our data. So you see that since it's JSON, there are different key value pairs that consists the real data. So we need to now, in the silver layer, we need to break this down and create a proper tabular structure. So we will reshape this data by extracting and renaming key attributes for further analysis. And once it's done, this is how the data will look like. So what I wanted to pay attention here, so we give a proper column name, and we also give columns aliases, and we now have a proper data type for each of the columns. So you can see that for latitude, longitude, we have decimal numbers. Updated is still not handled. This is the number of milliseconds since 1st of January 2019. We will handle this in one of the next step. So we will convert time and updated columns from milliseconds to timestamp. Essentially, what we are doing here in the silver layer, we are harmonizing data, cleaning the data, consolidating the data. That's the idea of the silver layer. And finally, I will append this data to the table inside the silver lakehouse. Table is called earthquake_silver. So I'm now saving the outcome, the result of these transformations in the silver table. Of course, during the demo, I'm executing all of these steps manually. In real life, these notebooks will be executed from the pipeline within the broader orchestration process. So if I now go to silver and refresh my tables, I'll be able to see earthquake silver table. And finally, inside the gold layer, I expanded it a little bit with using some Spark SQL code. So basically what we are going to do, we will first import some necessary libraries so we can extend Spark SQL code with user-defined function. And this user-defined function will be leveraged to extract the country code. So basically I'm registering my own user-defined function. Oh, this one uses a different environment. It will take some time to start the session. So while we are waiting, I'll go back and quickly explain what we have, a couple of more things, and then we will return because this will require at least 2-3 minutes to start the session. I'm using custom environment because I need some custom libraries here. I completely forgot to start the session before the demo. Okay, so we will, as I said, we will return to this. Just a quick, let's say, recommendation about different workspace designs in Fabric when it comes to Medallion pattern. So Microsoft recommends that you have a separate workspace for each layer, which makes sense to some extent, but it can also become a maintenance nightmare, especially if you consider implementing different environments for development, test, and production. So you will quickly end up with a huge number of workspaces. So what I'm implementing mostly in my practice and what I'm seeing that works in reality is to have one workspace and separate lake houses for different layers. So inside a single workspace, we have a bronze, silver, and gold lake house, or we have 5 lake house if you have 5 layers and so on. So each layer has its own lake house, but they are all within the same workspace. I strongly suggest that you take a look at this article. This is a brilliant article written by Will Krager. So there is a link here behind this. Maybe I can click on it and then share with all of you in the chat. So, okay, this was fast. In the meantime, we are creating a table and inserting the data from the silver table. On the way, we are performing some additional business specific requirements, such as transforming, extracting the country code from the latitude and longitude, and also assigning the class to our significance class to our earthquake events. So once it's done, we will check how does it look from the point. Okay, we have some issue here. I need to take a look. Okay, I'll take a look later because we are running out of time. So this is our scenario that was explained in a demo. Earthquake data that goes through different levels of organizing, cleaning, and harmonizing before it is served in the gold layer. To slowly wrap up, and then I'll go back, I'll take your questions and go back to try to fix this issue with the notebook. To wrap up this with some key takeaways. First and most important, Medallion is not a data modeling. So don't mix Medallion design pattern with data modeling. These two are not the same thing. The Medallion pattern is no more a data model approach than a parking lot is a type of car. I borrowed this sentence from Joe Rice, the author of Fundamentals of Data Engineering. I really like to quote this sentence whenever I hear someone talking about Medallion as a data modeling. The way I like to think about this is that each stage removes complexity for an increasingly broader and less technical audience. And a non-technical business analyst doesn't want raw JSON. They want a clean table to query. At no point do we prescribe how the data is modeled. So each stage is model agnostic. A medallion layer doesn't necessarily need to be a physical persisted data. In our previous demo, we materialized every layer in the lakehouse, but you can and you should take advantage of some advanced features and concepts available in Fabric, like shortcuts, for example. Shortcuts is a special one lake objects that point to the data stored in a different location. And by leveraging shortcuts, we are creating a virtual copy of the data without physically moving it. So this can be done in Fabric. So shortcuts, even the latest feature with shortcuts with transformations, which immediately transforms your CSV or Parquet files into a Delta format, or you can create views to encapsulate transformation logic without materializing the query results. Last but definitely not least, and I would say this is probably the main takeaway from today, there is no silver bullet medallion design. Something that works perfectly for company A might not be an optimal solution for company B, and vice versa. So carefully evaluate your specific use case and business requirements instead of blindly jumping on the bronze, silver, gold wagon just because you heard that's the only right way to do things. There are many different right ways to do things. Yes, they want nice table in Excel, of course. That's always absolutely true. Good point. Good point. So with that being said, that's all I had to talk about. Yes, no one said live demos. That's always challenging. I don't like pre-recorded demos. I'm always doing my demos live, and in most cases they work. But today was an exception. I'll try to fix this while we are talking. Yeah, if there are any questions, any comments, you would like to jump into a discussion. Sorry for going slightly over time, Halil. I hope it's not an issue.
We have plenty of time, Nicola, don't worry. Please, people in the audience, do not be shy. Feel free to ask any kind of question regarding the topic. Just unmute yourself, turn on your camera, and ask your question. Thanks a lot, Nicola. That was a hell of a session, definitely.
Thank you. Thank you.
There's so many debate around this definition invented or borrowed from someone else, like Databricks. But when you call something as architecture, then people think it's kind of physical layer, and that's not
Yes.
correct.
Absolutely agree. Absolutely agree. Yeah.
And the other thing, imposing some idea on people and expecting them to follow it as if it were a rule of thumb doesn't make any sense. It all depends on the situations, data type, where are you getting your data from?
Absolutely true. Absolutely true. Yeah. Absolutely true. Absolutely agree. So that's why I thought it makes sense to put all these thoughts into one session and try to spread the word among people, because there are a lot of misconceptions and misunderstandings when it comes to Medallion.
Exactly. And personally, I prefer giving end users the data model, not the data lake, data warehouse, or something like that. This is your semantic model. Let's train them about how to create your own reports. This is the way. The least painful process from my side, from my experience.
Yeah. I also like this approach when it says that as data goes through these processes, different processes and stages, for broader and less technical audience, it becomes more and more consumable and understandable. So that's the idea of this layered approach. However you call it, that's the idea of this layered approach. So that this final layer is completely understandable and easy to consume for the end user.
Yeah, there's a good question in the chat. Is there any benefit of using? Come on, pops up.
I see it. I see it.
Is there any benefit of using lakehouse over data warehouse, especially for gold layer?
Yeah. Well, not really. So we are talking about structured data, which is already highly refined, highly curated. So I don't see any specific benefit. It's up to some other choices that you need to make. So for example, if your data from the gold layer will be consumed in some other way other than, for example, Power BI. So if you have people that are running ad hoc queries and these people are familiar with T-SQL, you will probably go the warehouse way. Or if you have, on the other side, if you have people who are more proficient with Spark related languages, you will probably go with the lakehouse. But technically, I don't see any big difference. It's a matter of preference, really.
Agree.
I see a response from Emmanuel. We use shallow lakehouse to build direct lake semantic models. Yes, you can build also semantic model, direct lake semantic models on top of the warehouse. The only, let's say, advantage of having a lakehouse is that inside the lakehouse you can create shortcuts, which you can't do at this moment. You can't do that with warehouses. So if your goal there will be a series of tables that are used as shortcuts from other layers from other lakehouses, then it makes sense to use a lakehouse in the gold layer as well. Yeah.
Okay, question about your book, I guess.
Thanks, Fernando. Yes, so we are actively working on it. We have 3 chapters published as early release, but currently we have 6 or 7 chapters written and they are under technical review. So the official publishing date is somewhere in the end of spring or beginning of summer 2026. But yeah, we are already halfway through at least. Yeah.
we have
when you're
lots of
writing
time.
a book. Yeah, this is.
We have too much time until summer. Write fast.
Yes. We are doing our best, but it's not an easy job. Yeah, definitely.
Exactly. Writing an article is one of the most difficult things in the world. Even a small, you are holding a blog site for many years. Even writing a small article takes half day.
Yes. Oh, sometimes even more. Yeah, sometimes even more.
Exactly. Okay, your last chance, audience, please ask your questions. Okay, I think we are all done. Nicola, thanks a lot for this session. It was really informational, explaining everything regarding that architecture.
Yes. Thanks, Khalil. Thanks from my side. Huge thanks to everyone for joining. I know it's festive period, so maybe it's a good chance to everyone who celebrates Christmas. Merry Christmas, and yeah, happy holidays, happy New Year, and yeah, that's
okay. Happy New Year to everyone. Thanks a lot for joining us. See you, Nicola. Take care.
See you, Khalil. Thank you very much. Thanks for having me.